Hello friends, welcome to this lecture of Computer Organization and Architecture where I am discussing about the basic architecture of Microprocessor 8085. So in my last lecture I was telling about the details of the pins that you are watching, you are observing on the right hand side. Now in this lecture I am going to discuss about these pins which is lying on the left hand side of the Microprocessor 8085 in details. Starting with frequency and supply pin. When we come to the frequency and supply pin, we observe three of these pins. First pin is VCC. VCC basically act as a power supply pin. That means if we want to apply power to the microprocessor, it would be done on the VCC. Then we have ground, that means ground pin. That means one pin is attached with the ground, it's put as a ground. Next one is X1 X2. X1 X2 is basically the crystal oscillator. It is a very important thing that you have to understand. See, crystal oscillator is basically generate pulses. It basically oscillates to generate clock pulse. And every processor is associated with certain clock which generate clock pulse by the pin which generates a clock pulse, and this clock pulse is basically taken by the microprocessor to perform some arithmetic and logical operation. Do remember that clock pulse is a very important component inside the microprocessor, because as I told you that every processor has a clock which generates some clock pulses constantly, on the basis of which microprocessor performs arithmetic and logical operation. And crystal oscillator is basically the component which is able to generate the clock pulses inside the clock. So crystal oscillator basically works at 6 megahertz. It generates 6 megahertz frequency. But 8085 microprocessor basically work on 3 megahertz frequency. So in order to make the crystal oscillator compatible with a microprocessor, we basically introduce divide by 2 circuit. So divide by 2 circuit basically make the crystal oscillator to work at 2 megahertz frequency. Fine, and it is in the range of 2 megahertz frequency, which is able to make it to work within the range of microprocessor. So it is a very important thing that you have to keep in mind while talking about crystal oscillator. Let us now move on to the single data transfer pin. When we say single data transfer pin, we have the pin associated with in the form of SID and SOD. SID basically represent RIM instruction and SOD simply represent SIM instruction. So RIM and SIM instruction are basically used during the interrupt process, where if you want to read the interrupt and want to mask some of the operations of the interrupt, we basically make use of RIM, that is read interrupt mask. Then we have SIM, that is single interrupt mask. If we want to mask a single instruction of interrupt, we make use of the SIM. Then we move to the externally initiated pin. Externally initiated pin is associated with a set of the interrupts occurring inside the microprocessor 8085, and starting with we have trap, RST, that which you are seeing at this moment, RST stands for reset. We want to make the microprocessor reset to perform some specific task, and it has some associated code with it. And starting with trap has the code of RST 4.5. So RST has the highest priority among all the pins in the microprocessor 8085. So do remember that when we say trap is considered as the highest priority pin in microprocessor 8085, and this thing is has been basically asked in most of the examination, viva and the interview. So do remember that the trap has the highest priority among all the pins in microprocessor 8085. Moving next, we have other pins available like RST 7.5, RST 6.5, RST 5.5 and INTR. We will talk in details about it under the section of the interrupts. Now, hold and HLDA. What is the significance of that? So when we move to the hold and HLDA, they are basically used during DMA mode of data transfer. So when we make the transfer of the data in microprocessor, we have various ways to transfer the data in there, like CPU data transfer, like program input-output transfer, and DMA input-output transfer. So the third category, that is DMA input-output transfer, is basically make use of these two pins, hold and HLDA. When the DMA holds the hold pin, it simply implies that DMA takes over the control over the when hold pin is actually taken over by the DMA from the microprocessor, it simply take over the CPU to make the transfer of the data in microprocessor. So let us discuss the next three pins, that is a ready pin, reset in and reset out. Ready pin is basically used ready pin is basically used when CPU is going to attach with slow peripherals. Peripherals, as I told you in one of the previous lecture, that peripherals are basically the basic input-output device. And when we compare the speed of the basic input-output device like the keyboard or the monitor with the CPU, we simply come to know that the speed of such peripherals are always very slow as compared to the speed of CPU. So in order to make the speed of CPU compatible with the slow peripherals, we make use of the ready pin. Now next is reset in and reset out pin. Reset in pin is basically used when we want to start the microprocessor from beginning. That means we reinitialize all the operations of the microprocessor to begin working with a new instruction. And reset out means simply that once you have set the reset in pin, you have to reset out the pin in order to make to work over the other instruction. So that is all about the details of microprocessor 8085 architecture. We have to remember one more thing here, that is there are 5 low active pins in microprocessor. Very, very important. There are 5 low active pins in microprocessor. So this is all about the microprocessor architecture. Thank you.